Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have these problems minimize the maximum difference of pairs. Yeah. So these problems act as a medium, but I feel so it's kind of a medium hard. Like there is a tricks. This kind of problems is bound to be solved with common templates or the common patterns that we are following from our entire series. So if you know that, then I would suggest it's a medium for sure. But if you are altogether seeing these problems as a very new, very first times, then it is obviously a kind of hard for you for sure. Yeah, so you are given a zero index integer array nums and an integer p. Now we have to find p pairs of indices of nums such that the maximum difference among all the pairs is minimized. So that is very common trends. That is very common trends of the problems. So they have given a nums and they are basically asking you to find. They have also given a p factor. So p factor is basically that many pairs you have to find from your nums such that the maximum difference. So there can be AB is a pair, CD is a pair, DE is also a pair. So like this way, let's suppose you find all the pairs and you find the differences among all the pairs and out of them, which of the pairs is given the maximum difference is your answer, and that you have to minimize. And also ensures no index appears more than once amongst the p pairs. So note that for a pair of elements at the index ij, the differences of this pair is absolute of nums of I minus nums of j, where atho represents this represents the absolute difference of x. Now return the maximum differences of all the p pairs. We define the maximum of an empty set to be 0. So that is very straightforward. If your nums is altogether, let's suppose is empty, or let's suppose nums is holding a single element. So are you able to form any pair? No. So on that case, you can return 0 because there is no pairs at all. So yes guys, that is high levels on the problems, and your nums dot length can be as big as 10 raised to the power 5 and your nums of I can be as big as 10 raised to the power 9 and how many pairs is there, maximum number of pairs the nums has, that is nums length by 2 and the p factors they are looking for. So that many pairs they are looking for should be like within the all the possible pairs available to my nums within that range only. So p is always be bound to be a valid. So now if we can quickly go to our OneNote, so I know like if you are seeing these problems in a very first go, then this is kind of a like new to you, but yeah, like let's quickly discuss that. So what actually they are looking for. So if I'm going to consider that you have some like a, what happens, it's selected this. Yes, so can I write it now? Can I write? What's going on? Yes, I can write. So let's suppose we have A, B, C, D, E. So let's suppose we have these things. That is our nums. So, and let's suppose P is 2. P is 2 is given to. Now so that means you have to select 2 pairs. So A can pair with either B, either C, either D, or either E. Similarly, let's suppose we considered, let's suppose A and C has paired up. So one pair is AC. Let's suppose another pair we done with B and E. Let's suppose we done that pair, and that is of B and E. And the differences of AC, let's suppose, is nothing but, let's suppose, C minus A is of absolute, and this BE is B minus E is of absolute. So that is the gap. So now so as there are only 2 pairs, now what you have to return, let's suppose this pair has lesser, let's suppose C minus A is smaller than B minus E. Let's suppose we have like this way, let's suppose our P is n by 2, so like this way, let's suppose we have another pair, X minus Y is another pair, then Q minus R, let's suppose another pair, and out of them, let's suppose C minus, what is the largest pair? So the pair, what is the largest one is Q minus R. Let's suppose this Q minus R. So in that case, on answer, you have to return Q minus R's absolute difference. Now where the minimize factors is coming there? So again, take the same example, discuss A, B, C, D, E. So previously we done a pair of AC and B, E. So A minus C is a pair and B minus E is another pair. So here, focus guys, here we are actually trying to build the intuitions. Every problem has an intuitions. If you are able to build an intuitions, then that is kind of a like cakewalk for you. So please focus on the intuitions building part. So let's suppose on this, who is the maximum? Let's suppose this b minus e is the maximum, and we got b minus e as 5. Let's suppose for suppose b minus e is 5, 8 minus c, let's suppose 4, and we have to define on this particular arrangement, in this particular arrangement, what difference giving me the maximum, so that we have to return the 5. Now where the minimize factor is coming. Now let's suppose we done a pair of a minus c as it is, and we done a pair of this c and d. Let's suppose for we done a pair of cd in another permutations combinations. That is also valid. That is also valid. Sorry, cd not valid because we already done ac. Let's suppose we done b and d these times. Rather than b and d, let's suppose we done a b and d. So in this case, we know it is going to be 4, and let's suppose b minus d is coming to be as 3. Now what is the maximum among them? Is 4. So on this particular arrangement, we got the maximum difference as 4, right? Let's suppose we are trying to build another combination. Let's suppose we took a minus b, and let's suppose we do c minus d. And here, let's suppose a minus b is coming as 3, and c minus d, let's suppose is coming as c minus d is coming as 2. So in this case, what is the maximum? Maximum is 3. So like this way, in which arrangement? So that is, so if I am going to number them, so that is the first arrangement, that is the second arrangement, and that is the third arrangement. So on which arrangements we got the minimize answer? So on third arrangement, agree guys, on third arrangements we got the minimize answer. And what is this? 3, right? So how we are checking? Between first arrangements we got the maximum as 5, second arrangement we got the maximum as 4, and on third arrangements we got the maximum as 3. Out of them, who is the minimum? All the maximums of different permutations combinations we done, who is the minimum? 3 is the minimum. So we returned our answer as 3. So that is our answer. So I guess this is bound to be your problem clarifications should get clarified, but if not, I will repeatedly request you, please rewind this particular segments if you are still not able to understand. So we have to find at least, we have to find p pairs. We have to find p pairs on different permutations combinations. We can pair a with either b, a can pair with c, a can pair with d, right? So like this way, every numbers can pair with another ones. But please focus that in a particular arrangements, if we choose a and b, then we can't choose b and c, because so that is not valid. We can't do, because b is already a part of a pair. That we can't do. So that is mentioned on the problems. You can't take a single elements twice in different pair segments. Twice or more, you can't do. So every number should be distinct, and what is the pairs you are able to build with the most optimized permutations combination select. You have to return the maximum of all the pairs. What is the maximum? And to choose the pairs, you have to choose very optimally, so that your maximum is going to be minimized. I think from this you guys definitely get the hints. If you have to minimize your maximum, maximize your minimum, so that is very standard, very standard of binary search on answer. So if you are getting hints, so that is a hints. So on the problem itself, they will going to give you a hints. So minimize your maxes, minimize your maximums, right? Or maximize your minimums. So this is very standard hints to think about at least once of binary search on answer. We have solved lots of videos of these particular topics. If you are not know, I will definitely suggest to go to some of the past video of our binary search playlist. Post that you can jump on this particular video, or even you don't need to jump on this particular video, you are able to solve it on your own. So binary search on answer, think about of this at least once. So that is a very common hints to think about this. Now though we know we can use binary search on answer, but Shouvik, it's still not clear. We are going to get the fields. We are not going to get the fields. So please give us the fields also, how binary search on answer is going to be fit here. Yeah, like before that, I would suggest there is one more clear observation. So is there is a very greedy observation is there. If how you can going to get the delta of the pairs. Let's suppose the array is not sorted. A, B, C, D, E, whatever the array they have given, it is unsorted. So which pairs are giving to you the minimized gap? So that's exactly we have to do. So the pairs that we are selecting should have the gap between them is minimized. So let's suppose this A is also 1 and this E is also 1. E is also 1. So we definitely need to pair this A and D. We definitely need to pair this A and D. Let's suppose this B is 1, this D is 2, and this C is, let's suppose, 5. Then whom are you going to pair? This 1 and 2 you have to pair, because on that case the delta is minimum. The delta is minimum. So we know if that is kind of a sorted, it is right now in unsorted. But if we do a sorting, let's suppose if we do a sorting, then it becomes 1 1 2. Sorry, one more 1, 1 2 3 ones and 2 and then 5. Now you can see the beauty. You can see the beauty. Our numbers are whom we are greedily choose to be a pair are in adjacent only. Because we have sorted, and we know if this 1 and 1 is, the gap between 1 and 1 is bound to be less than equals to the gap between these elements and these elements. If we are going to pair these elements to just of its neighbor elements, just of its right neighbor elements, then only we are going to get the very minimum gap. So if we are skip these elements, and if this elements is trying to pair with these elements, then I know either the gap is same or it's bound to be increased. So here you can see this 1 1 is 0 only, this 1 1 is also 0, but here it's increased. So that's the reason I written here less than equals to. So if your array is sorted, and if you are doing pairing of your neighbor elements, so that is the most optimized pairings you can achieve. That is very greedy. That is of very greedy observations. That is a very greedy mathematics observations. Because here if this 1 is giving, 1 is bound, this ones whom you are going to pair just of its adjacent elements, because it is sorted. If you are going to skip these elements, and if you are trying to pair with some of the righter elements, as the array are sorted, so it's bound to give more gap. It's bound to give more gap. And what is our tendency? The gap between all the pairs should be minimized, so that our maximum among all the pairs should be minimized. The maximum of all the pairs should be minimized. So every gaps that we are already worded, right, that we are already told that we have to optimally choose such that the maximum gap is minimized. So the optimal choose is nothing but this. Sort your array and then try to pair it with its adjacent. Like this way, you are going to get all the times the optimized gap. Agree? Totally agree, guys. Now we can. Now that is the basic observations that we have to be put, and that is the intuitions is lying to your actual like problem solving or the intuitions building. Now we have to define a concrete algo. Now we definitely have to define a concrete algo. So we know we can do a binary search on answer. So let's try to set our template. So let's try to set our L and R first. So our L, what is the minimized possible value of our answer? What is the minimized? We are doing binary search on answer. What is the minimum possible value of our answer? Let's suppose all the elements are equal. Then on that case, you are going to take every pairs, and every pairs have a delta between them is 0. So our minimum possible answer is 0. And what is the maximum possible answer? Is nothing but if you sort. So we know we definitely need to sort our array, because to play the above game, because adjacent elements should give the minimized gap. The adjacent elements should give the minimized gap. And what is the maximum possible answer? Is nothing but in my sorted array, what is the last value? Nums of -1 minus of nums of 0. So that is the maximum gap. That is the maximum gap in my answer, and that is the maximum possible answer value. Now we can standard template we can put here. We can initialize our answer to be 0, and while my left less than equals to R, I can choose my mid. Equals to L plus R, right shift by 1. Yes, and if I will write a helper functions with this mid, I am just writing my standard template. Then we will see if this is going to be sufficient or we need something extra. That is the standard template of binary search on answer. If you don't know, I will definitely suggest please go to at least see 2 to 3 videos of our binary search on answer playlist. Then we'll definitely get the gist. I am writing the standard templates. We are not doing any top of logic. So our answer should be, we will make it as mid, and if with this we are able to build our answer, what we are trying to minimize our answer. Then on which side the answer is minimized? So R should be nothing but mid -1. Then we can search to R should be my mid -1. So whatever the index we have searched to our mid. So till this mid answer is possible, can you search some lower index? Can we search some lower possible search scope? Can we string down your search scope to some lower indexes? So how we can move to lower index? R should be my mid -1. Else my left should be very standard template. to be mid plus 1. Till now answer is not possible. Can you try to increase your possible answer boundary to be somewhere higher, so that we can build our answer, There is definitely a monotonous sequence there. Finally, we can return our answer. Okay, Shouvik, everything is good. You have written your own template, but what about helper? How helper is going to decide on which directions your binary search should move? In which directions the binary search should move? So now let's try to write the pseudocode for our helper. So our helper is nothing but tell us with this particular target, we are passing the mid as a target to our helper. With this particular target, can we find p pairs? Such that the gap, the maximum gap of all the pairs of all the p pairs or how many pairs, or more specifically I can write how many pairs in my array, in my nums having gap less than equals to my target. How many pairs in my array, in my nums having gaps less than equals to my target. And if this count, how many, it's giving me a count. If this count is greater than or equals to my p, then can I say with this gap, with this target, I have sufficient pairs. Sufficient pairs is how many pairs we have? We have count number of pairs. We have sufficient count number of pairs to form at least p pairs. So for this target, we have at least p pairs for which the gap is less than equals to target. So we can return a true. Or if that is not possible, then we can return a false. Yes. Now let's try to build the how we can count it. So we can definitely start our count to be 0. I think it's going to be a very simple now, and we can start our I to be at 0, and while my I plus 1 is less than n, because we are going to check the adjacent, our right is also should be inside the boundary, so that we can check. Now what is the check? As our array is sorted, so nums of I plus 1, it is within the boundary because our while is taking care of is less than, nums of I minus nums of I plus 1 minus nums of I. If that is less than equals to whom? Equals to my target. Okay, that is a then valid pair. Then we can write it, we can stump it. What we can stump it? We can obviously increase our count plus. Yes, we got a valid guy. And do I need anything? Yes. Then on that case, we need to skip both the indexes. Because otherwise, if I am going to move I plus equals to 1, then I plus 1 we already have a pair. No, I plus 1 is already considered to this current pair. So we have to go to I plus equals to 2, because so that I plus 1 is already in the part, so that it is not going to be twice calculated. Any index is never going to be considered twice. That we have already saw in the constant. Else, if this pair is already higher, then we should go to simple I plus equals to 1, I plus plus. Simple I plus plus we can do. And finally, if after this entire for loop executions, if our count is greater than equals to p, then return a true, and else return a false. As simple as that, guys. As simple as that our helper should be. Exactly these things you have to just write. You have to write, guys. Now we can quickly go to our code iterations. I have written exactly same things I have written. So n is len of my nums dot sort. We have sorted it out. Now LR we have initialized, LR and answer we have initialized to 0. L should be 0. R should be my nums of minus 1, minus of nums of 0. That is the maximum possible answer boundary. And our answer we have initialized to be of 0. Now while my left less than equals to my right, that is the standard templates we have written. While my L less than equals to R, mid equals to L plus R by 2. So right shift by 1 means divided by 2 of any numbers. We already should know after solving 90 plus videos. If helper of mid, so that is our functions. We will see if it is giving us true. So with this particular mid, answer is possible. So that means you should be able to form p pairs in which the maximum gap is less than equals to your target. Your target is mid. So store your answer to be mid. So that much gap is possible. Can you trim down more to your gap? Because we have to minimize it. How we can do? R should be mid minus 1. Exact same things, guys. Else else should be mid plus 1, and finally we are returning our answer. Now on the helper functions, see guys, that is the beauty actually. Writing on template format code, that is the beauty. You don't have to think lots. You just write your code and in the exact same template it will work. It will definitely work. And your helper functions is going to be a problem to problem specific. Else you can see, else on any part you guys are able to see any extra delta we have write apart from our template. No guys, no. So only helper, helper is the question specific things we have to write. On helper, it is going to return bool for sure. Count should be 0. We are starting with 0, while I plus 1 less than equals to n, because I plus 1 should not be out of boundary. So that's the reason we are iterating. So I plus 1 is also should be less than n, so that we can do the comparisons. While my nums of I plus 1 minus nums of I less than equals to target, then increase your count to be plus 1 and I plus equals to 2, right? Because we should go to jump from I to I plus 2, I to I plus 2, right? Else increase your I to I plus 1, right? Else increase your I to I plus 1, because with this we are not able to get less than target, so that I can be a part of your I plus 1. Otherwise this I plus 1 is already considered, so directly jump to I plus 2, directly jump to I plus 2. Very straightforward, that we just saw in the one. And if our count is greater than equals to 3, return true, else return false. Yes, exactly as simple as that, guys. Now we can quickly discuss the time complexity. I guess you guys should write the time complexity of your own, but as for formality, we will definitely write the time complexity. Here nums.sort going to take off big of n log n plus this L2R. What is the boundary? That is of 10 raised to the power 9. So if I can nums of I, if I am going to write it in kind of m, so it is going to be a takeoff big of log m. M is nothing but 10 raised to the power 9 in very worst case, right? Big of log m, and inside that log m, this iterations, this helper functions is working in big of n for sure. So big of m into n. So in general, I can write it big of n log m, right? I can write it. Yes, that's it all about. Apart from that, all our variables on space complexity, guys, tell me, all our variables, right? All our variables play on it. We are doing all our variables plug and play. So the space complexity is big of 1. Time complexity is this, and space complexity is bound to be big of 1. Now, can we Leetcode is also predict the time complexity? Can you predict, man? Or your server is busy? Predict, please predict. Your server should not be busy, man. So here you can see exact, that is big of n log n plus big of n into log diff. Diff is nothing but the m factor. See guys, how beautifully we are writing the time complexity. That's the way you have to write your time complexity for any interview. See, exact match. Big of n log n plus big of n log diff. Big of n log n plus big of n log m is nothing but the diff. And on space complexity, we are of sure big of 1. There is no chance. Why it is big of n? I'm not sure. It's indeed not. It's big of 1. Are we sure, guys? It's big of 1. Let me just quickly check. Nums.sort is an in-place sorting we are doing. LR variables, everything's variables here. Yeah, man, it's for sure big of 1. We are playing the games with nums.sort in place. We are not doing a sorted functions. If we are doing a sorted functions, then it is create a new loop, new what can I say? New memory altogether of the nums. But as we are playing with nums.sort in place, it's for sure of big of 1. It is of in place sorting. So yes guys, so that is the most optimized time and space complexity that I am able to think of, and I'm pretty sure it is kind of a more than 80% faster than all the time perspective of all the submissions over the Leetcode, and it is indeed the most optimized time and space complexity with more readable, more granular format you can achieve of these particular problems. So that's it guys for this particular video, and if you guys are able to understand the entire intuitions, entire whiteboardings, entire time and space complexity, and with the code iterations that we done, so I guess you guys are already doing. So please do subscribe to our channel. Please share the videos to your friends circle who are also preparing for top product based company and brushing up their TSS skills, and please turn on the notifications so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another video question. Bye guys, bye.